Hello everyone. Today let us discuss about intensifying screens. Welcome you all to Oral Medicine and Radiology Made Easy. Please subscribe to this channel for more updates. What is intensifying screen? It's a smooth plastic sheet coated with minute fluorescent crystals known as phosphors. When exposed to X-rays, these phosphors fluoresce and emit visible light in the blue or green spectrum. So, intensifying screen is a smooth plastic sheet coated with minute fluorescent crystals known as phosphors. And when exposed to X-rays, these phosphors fluoresce and emit visible light in the blue or green spectrum. Here we came across a term phosphor. So, what is phosphor? Don't confuse it with phosphorus. Phosphorus is different and phosphors are different. Intensifying screen is a device that transfers X-ray energy into visible light, and the visible light in turn exposes the screen film. And presence of intensifying screen makes the film 10 to 60 times more sensitive to X-rays. So let us understand how it works. So here is a X-ray tube, and this is the subject, and here is the X-ray film which captures the image. So in a normal scenario, the X-ray beam passes through the subject and it creates an image on the X-ray film. Now in case of intensifying screen, what happens is, little X-ray beam is required to form an image of the same subject. So the X-ray beam falls on the subject and then it falls on the intensifying screen. Observe that the amount of X-ray required to expose the same subject is less when the intensifying screen is used, and the X-ray beam passes through the subject and then it falls on the intensifying screen. Intensifying screen will not only convert it into visible light but also multiply it into various beams of visible light. That is, it's been multiplied 10 to 60 times, and this visible light will expose the X-ray film. So the purpose of using intensifying screen is to reduce the amount of X-ray exposure. So what is the purpose of using the intensifying screen? They are used because they decrease X-ray dose to the patient. They are used in all extraoral radiography including panoramic, cephalometric and skull projections. And in all dental applications, intensifying screens are used in pairs, that is, one on each side of the film, and they are positioned inside the cassette. So the X-ray film used with intensifying screen has photosensitive emulsion on both the sides because it's sandwiched between two intensifying screens. Since the film is sandwiched between two intensifying screens in a cassette, the emulsion on each side is exposed to the light from its contiguous screen. The screen absorbs energy as well as the information in the X-ray beam that has penetrated the patient and convert this energy into a light pattern that has the same information as the original X-ray beam. The light then forms the latent image on the X-ray film. As I have already mentioned, the screen absorbs the energy in the X-ray beam that has penetrated the patient and convert this X-ray energy into light pattern that has the same information as that of the original X-ray beam. The light then forms the latent image on the X-ray film. The transfer of information from the X-ray beam to screen and from screen light to film results in some loss of information. And this is the main disadvantage of using intensifying screens. Now let us understand what are phosphors. It's a substance that emits light at a temperature below the temperature at which it would exhibit incandescence. So it emits light at a temperature below the temperature at which it would exhibit incandescence. Now let us understand few terminologies. Luminescence, fluorescence and phosphorescence. Luminescence refers to emission of light by a substance. So any substance that emits light is known as luminescent substances. Now what is fluorescence? Fluorescence is a form of luminescence produced when the light is emitted immediately or instantaneously, that is within 10 to the power of -8 seconds. If a substance is stimulated by some energy and if it emits light within 10 to the power of -8 seconds, then it's called as fluorescence. Whereas in phosphorescence, it's a form of luminescence produced when the emission of light is delayed beyond 10 to the power of -8 seconds. So when there is immediately emission of light, it's called as fluorescence. And if there is a delay and later on there is emission of light, it's called as phosphorescence. Now, the intensifying screen is based on the principle of fluorescence or phosphorescence. Since the emission of light is immediately after the exposure of X-rays, intensifying screens are based on the principle of fluorescence. Then what is based on phosphorescence? You must have seen the radial dials in a watch. These radium dials emit light sometimes after exposure to light. This is called as phosphorescence. There are 3 stages in the functioning of intensifying screen. First, there is absorption. That is, incident X-ray photons are absorbed in the phosphor and secondary electrons are produced. Then there is conversion. The energy available from the released electron is converted to light photons by fluorescence. Remember, intensifying screen is based on the principle of fluorescence. That is, energy is immediately converted to light photons. And then there is emission. That is, photons leave the phosphor material and expose the film. So the 3 stages in the functioning of intensifying screens are absorption, conversion and emission. Some screen films are sensitive to blue light, whereas others are sensitive to green light. How to know whether the screen films are sensitive to blue light or green light? I'll show you at the end of this presentation. What are cassettes? Cassette is a special device that's used to hold the extraoral film and the intensifying screens. These intensifying screens are held with the help of a cassette. So, this is one intensifying screen and here is another intensifying screen, and this entire holder is known as a cassette, and the film is placed in between the 2 intensifying screens. A screen film is sandwiched between 2 intensifying screens and is secured in a cassette. This is the front screen, here is the X-ray film and here is the back screen. The front screen absorbs the low energy X-ray photons and the back screen absorbs high energy X-ray photons. So the front screen absorbs low energy X-ray photons. The back screen absorbs high energy X-ray photons. The 2 screens are therefore efficient at stopping the transmitted X-ray beam, which they convert into visible light by photoelectric effect. Coming to the composition of intensifying screen. It has basically 4 parts. First is a base or a support made of plastic or cardboard. Next, a reflecting layer made of titanium dioxide. Next is a phosphor layer and then the plastic protective coat. The thickness of a typical intensifying screen is about 0.4 mm. Base is made up of polyester plastic, which is approximately 0.25 mm thick. The function is to provide mechanical support for other layers. Next is reflecting coat. The light produced by interaction of X-ray photons and the phosphor crystals is emitted in all directions. Much of the light is emitted from the screen in the direction of the film. However, there are also directed towards back of the screen. The reflecting layer acts to reflect the light back towards the front of the screen. This results in some image unsharpness because of divergence of the light rays reflected back to the film. This is again a disadvantage of using intensifying screen. The reflecting coat is made up of white substance called as titanium dioxide and is spread over the base in a thin layer. You can see this is the reflecting layer which is placed next to the base and phosphor layer. So whatever X-ray photon is reaching the reflecting layer, it will divert it back to the film. Next is phosphor layer. Phosphorescent crystals suspended in a polymeric binder. These crystals absorb X-ray photons and then they fluoresce. The phosphor crystals contain rare earth elements, mostly lanthanum and gadolinium. So lanthanum and gadolinium are most commonly used phosphor crystals in an intensifying screen. Their fluorescence can be increased by addition of small amounts of other elements such as thulium, niobium or terbium. So the rare earth elements used in intensifying screens which emits green light is terbium activated gadolinium oxysulfide, and which emits blue light is niobium activated yttrium tantalite. The next layer is protective layer. It is placed over the phosphor layer to protect the phosphor and provide a surface that can be cleaned. This layer has three functions. It helps to prevent static electricity. It gives physical protection to the delicate phosphor layer and provides a surface that can be cleaned without damaging the phosphor layer. The efficiency with which the phosphor converts X-rays to light is termed as intrinsic conversion efficiency of the phosphor. Now, what are the disadvantages? One is it decreases image resolution and they can't be used intraorally with periapical or occlusal films because their use would reduce the resolution of the resulting image below that necessary for detailed evaluation of the dental disease. So, if we use it intraorally, we might not get the good resolution image which is required for evaluation of a dental disease. So, these are the drawbacks of using intensifying screen. Now, let us see how we can check if the screen is a green light emitting or a blue light emitting. Just expose the X-ray into the intensifying screen. Here you can see it is emitting green light. Let me show you again. Here you can see it is emitting green light. So the film used with this are green light sensitive films and this intensifying screen emits green light. To understand this, you need to just expose the X-ray into the intensifying screen and then you can see the color of the light emitted from it. Now let's recap. Intensifying screens work on the principle of fluorescence. They are used only in extraoral radiography. They help to reduce X-ray dose to the patient. The benefit of using intensifying screen is that they reduce the X-ray dose to the patient. The main disadvantage is that they decrease image resolution. So please don't forget to subscribe, like and share this video. Thank you.